What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 11, Section 6, Solving Systems with Gaussian Elimination. Let's do it. Question number 1. Can any system of linear equations be written as an augmented matrix? Okay, explain why or why not. Explain how to write the augmented matrix. So I would say generally yes. So let's write out an example. Let's say we have 2x plus 7y equals 3, 4x plus 8y equals 9. Okay, so just a random system. The way that you can write it out as an augmented matrix would be you take the coefficients of the variables, right? 2, 7, and again, they're lined up, right? 2, 7, 4, 8. And then these little constants over here, the 3 and the 9, are going to go past the bar like this. So you can pretty much do this for any system of equations. The constants over here, coefficients here, that's how you do it. Done. Is there only one correct method of using row operations in a matrix? Try to explain different row operations possible to solve the augmented matrix. So, of course, what we're going to do here theoretically is use Gaussian elimination, right? Try to get that nice identity matrix here where we have 1, 1, and 0, 0, and that will get us to our solution. But yeah, there are multiple ways to do it, right? I could start off by multiplying the first row by 1/9 and turn that into a 1, okay? That's one option, and then I could go from there. Another option is I could start by simply adding this entire row to row 2, and that would flip this to a 1, right? And then we could take it from there and start flipping everything. The bottom line is there are different potential order of operations that will still get you to whatever the correct solution is. So I would say yes, there are multiple possible different row operations. Done. Can a matrix that has 0 entries for an entire row have one solution? Explain why or why not. So I would say no to this. Let me give you a quick example here. So we'll draw out in augmented matrix, and I'll say 1, 1, 7, and then the entire bottom row is zeros. So in this case, this is basically saying like this is all zeros. That doesn't tell us anything. And then here we have 1x plus 1y is equal to 7. So this is an infinite solutions or solution situation where x could be 3, y could be 4, x could be 2, y could be 5, etc., etc. So we're gonna say that 0 entries for an entire row. No, it's not possible to have one solution. Done. So for this one, when I put it in an augmented matrix, first I'm going to rewrite the first one as 0x plus 16y is equal to 4. And then I'll keep the second one as is. And the reason why is because, we need to have the correct coefficients and the constants so we know what goes where. Now, if I transplant it into this augmented matrix, it's literally 0, 16, right? Those coefficients. And then here 9 and -1 for the bottom one. And then the constants on the other side, 4 and 2. That's how you do it. Done. So before we start this one, the only thing I'm going to add in here, see how it says equals 4? I'm going to just change it to 12x plus 3y plus 0z. Just remember that there's a 0 there for that z spot, because technically it's an invisible 0z, right? Equals 4. Now we have a coefficient designated for each one of the variables. Okay, now let's put this into augmented matrix form. So for that first equation, we got the coefficients 1, 5, 8, right? And then we got for the second one 12, 3, 0, okay? Then for the third row, we got 3, 4, and 9 for those coefficients. And now for the constants on this side, we got 19 at the top, we got 4 in the middle, and -7 at the bottom. That's how you do it. Done. So for this question, we're turning this into a linear system. So again, remember, these are the coefficients of the x, coefficients of the y, and the constants. So we can write this as -2x plus 5y is equal to 5. And down here, we got 6x minus 18y is equal to 26. That's how you do it. Done. For this one, we're meant to turn this back into a system of equations. And now we got 3 columns. So this represents x, y, and z. And these are the standalone constants. So let's write them out. We got 3x plus 2y plus 0z. So I don't need to write that, is equal to 3. Then we got -x minus 9y plus 4z is equal to -1. Last row, last but not least, we got 8x plus 5y plus 7z is equal to 8. That is how you do it. Done. For this one, since we have 3 columns, note that these go with x, y, z, and these are the standalone constants. So now let's write that out. We got, for the top one, 4x plus 5y minus 2z is equal to 12. Second row, we got 0x, I'm not going to include it, plus 1y plus 58z is equal to 2. Last but not least, we got 8x plus 7y minus 3z is equal to -5. That's how you do it. Done. For this system, we're meant to solve by Gaussian elimination. Now, the idea with Gaussian elimination is for a 2 by 2, we need a 1 here and a here and zeros here and here. The problem with this is there's no way that I'm going to be able to turn this into a 1, right? I can turn that into a 0 by multiplying the top row by -1 and adding it to this one, but I'm just not going to be able to flip it. Also, this gives two contradictory answers, right? This implies that x equals 1. This implies that x equals 2. Obviously, that can't be a thing, so this is a no solution situation. Done. So for this one, remember, we want to get these four in that nice identity matrix like so, and then we'll have our values. So as we start, I'd love to flip that to a positive 1. So I'm going to multiply row 1 by -1. So we're going to rewrite this as 1, -2, and that's going to be a +3. This is going to stay as is. Next, I'd love to flip that to 0. So I'm going to multiply row 1 by -4, add it to row 2, and that's going to be my new row 2. Let's write that out. So we got -4 plus 4 is 0, +8 plus -5 is 3, and -12 plus 6 is -6. Great. Okay, now let's flip this guy into 1. So I'm going to multiply, let's do it up here. I'm going to multiply row 2 by 1/3. So let's check that out. So we got 1/3 times 0 is 0, 1/3 times 3 is 1, 1/3 times -6 is -2. Great. Last but not least, we got to flip that to a 0. So I'm going to multiply row 2 by +2, excuse me, and then add that to row 1 to get a new row 1. Let's write that out. So we got 2 times 0 plus 1 is 1, 2 times 1 is 2, plus -2 is 0, and then 2 times -2 is -4, plus 3 is -1. And there we have it. We got our two solutions. We got x is -1, y is -2. There's your answer. Done. So for this one, we want to first put it into a nice augmented matrix. So let's start there. So we got 2, then we got that coefficient -3, here we got 5, and we got 4, and then the constants over here, -9 and 58. Okay, my first objective is to flip that to a 1, so I'm going to multiply the top row by 1/2. My first objective is to flip that to a 1, so I'm going to multiply the top row by 1/2, so let's write that out. So we got half of 2 is 1, half of -3 is -3/2, and then half of -9 is -9/2. Great. Now let's flip that to a 0. Let's multiply row 1 by -5, and then we're going to add it to row 2 to get a new row 2. Let's write that out. So we got -5 times 1 is -5, plus 5 is 0. -5 times -3/2, that's 15 over 2, which is like 7.5. Plus 4 is, I'll just go decimal, 11.5. It doesn't matter. And then we'll do -5 times that is 45 over 2, which is 22.5. Plus 58 is 70, 80, 80.5. Again, we're trying to get 1, 0, 0, 1 in that order. So maybe next, let's flip this to a 1. So I'm going to divide the second row by 11.5, aka multiply it by 1 over 11.5. So that times 0 is 0. That times 11.5 is 1. And this times 80.5, believe it or not, goes in nicely. It goes in exactly, 11.5 goes in exactly to this 7 times. So that's a nice answer there. Okay, last but not least, we got to flip that to 0. So I'm going to multiply row 2 by 3/2, and I'm going to add it back to row 1 to get a new row 1. Let's write it out. 3/2 times 0 is 0, plus 1 is 1. 3/2 times 1 is 3/2, plus -3/2 is 0. Last but not least, 3/2 times 7 is 21 over 2. So 21 over 2 plus -9 over 2 is going to be 12 over 2, and that simplifies to 6. So there's your solution. X is equal to 6. Y is equal to 7. That's how you do it. Done. All right, so for this one first, let's put it into our nice matrix format. Okay, so the first thing I'd love to do is flip that to a 1. So I'm going to multiply row 1 by 1/2. So let's write that out. Half of 2 is 1, half of 3 is 3/2, half of 12 is 6. Cool. Now I'd love to zero this out. So what I'm going to do is I'm going to multiply row 1 by negative 4, and I'm going to add it to row 2 to get a new row 2. Let's write it out. So we got negative 4 times 1 is negative 4, plus 4 is 0. Negative 4 times 3 halves, that's negative 6, plus 1 is negative 5. And then negative 4 times 6 is negative 24, plus 14 is negative 10. Next, again, I'm trying to get 1, 0, 1, 0 like that. So next, let's flip this one to 1, and I can do that by multiplying the bottom row by negative 1/5, the reciprocal of negative 5. So negative 1/5 times row 2, let's write it out. So negative 1/5 times 0 is 0, negative 1/5 times negative 5 is 1, and then times negative 10 is 2. Great. Last but not least, we got to flip that to 0. So let's multiply row 2 by negative 3 halves, okay? And we're going to add it to row 1 to get a new row 1. Let's write it out. So negative 3 halves times 0 is 0, plus 1 is 1, times 1 is negative 3 halves, plus 3 halves is 0. And then times 2 is negative 3, plus 6 is positive 3. So there's my solution. It is 3 for x, 2 for y. That's how you do it. Done. For this one, let's first put it into matrix format. And now let's start by flipping that to a positive 1. So I'm going to multiply the top row by negative 1/5. Let's write that out. Negative 1/5 times negative 5 is 1, times 8 is negative 8/5, and times 3 is negative 3/5. Great. Now I'd love to zero this out. So I'm going to multiply row 1 by negative 10. I'm going to add it to row 2 to get a new row 2. Let's write it out. Negative 10 times 1 is negative 10, plus 10 is 0. Negative 10 times negative 8/5, that is 16, I believe. And then 16 plus 6 is 22. And then negative 10 times negative 3/5, that is positive 6, plus 5 is 11. All right, great. Now I'd love to flip this into 1. So I'm going to multiply the bottom row by 1 over 22, the reciprocal of 22. Let's write that out. So that times 0 is 0, that times 22 is 1, that times 11 is 11 over 22, which is 1/2. Great. Okay, last but not least, we need to flip that to 0. So I'm going to multiply row 2 by positive 8/5, add it to row 1, and that's going to give us our final row 1. Let's write that out. So we've got 8/5 times 0 is 0, plus 1 is 1, times 1 is 8/5, plus negative 8/5 is 0, and then times 1/2. 8 times 1 is 8, 5 times 2 is 10, so that's 8/10, which is the same as 4/5. 4/5 plus negative 3/5 is 1/5. So there's our solution. X is 1/5, y is 1/2. That's how you do it. Done. For this one, let's first put it into our matrix format. So right off the bat, I see something kind of interesting. I can multiply the bottom row by 3 and add it to the top row, and we're going to zero some things out. But notice what happens. So let me show you this first. Let's do 3 times row 2 plus row 1 is going to equal our new row 1. So 3 times 20 is 60, plus negative 60 is 0. 3 times negative 15 is negative 45, plus 45 is 0. And then 3 times negative 4 plus 12 is, negative 12 plus 12 is 0. So we got a full row of zeros, okay? So when we have this situation, this entire equation is zeroed out. What it's really telling us is that these two equations are exactly identical, all right? So if they're exactly identical, this means we're going to have an infinite solution situation. So now let's go back to this equation. I'm going to rewrite it in sort of our regular linear equation format, which is this, right? 20x minus 15y is equal to negative 4. So what we have here is we have a relationship between x and y with infinite possible solutions. And so what I'm going to do is I'm going to isolate y. I got negative 15y is equal to negative 20x minus 4. And I'm going to divide everything by negative 15. I got y equals negative 20 over negative 15 is 4/3. So that's 4/3 x. And then it's plus, because negative 4 divided by negative 15 is positive 4 over 15, okay? So what are my values if I want to say, hey, this is the acceptable zone of infinite solutions? Well, if x is x, right, y is going to be, in terms of x, 4/3 x plus 4/15. So this right here would encapsulate all the possible infinite solutions. Done. So for this one, let's put it into matrix format first and foremost. All right, so first let's start with this. We're going to flip that to a 1 by multiplying row 1 by 1/2. Let's write it out. Half of 2 is 1. Half of negative 1 is negative 1/2. Half of 2 is 1. Great. Now let's flip that to a 0. I'm going to multiply row 1 by negative 3. add it to row 2 to get our new row 2. Let's write it out. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times negative 1/2 is positive 3/2, plus 2 is going to be 7/2, right? Because 2 is 4 over 2. 4 over 2 plus 3 over 2 is 7 over 2. And then negative 3 times 1 is negative 3, plus 17 is 14. Great. Okay, next I'd love to flip that to a 1, and I'm going to do that by multiplying the reciprocal of 7/2, which is 2/7 times row 2. Let's write that out. 2/7 times 0 is 0. 2/7 times 7/2 is 1. And then 2/7 times 14, it's like you divide 14 by 7, which is 2 times that numerator of 2, which gives us 4. Great. Last but not least, we need to get rid of this. I'm going to do that by multiplying row 2 by 1/2, right? Turning that into 1/2, and then adding it to row 1 to get our new row 1. Okay, let's write it out. 1/2 times 0 is 0, plus 1 is 1. 1/2 times 1 is 1, plus negative 1/2 is 0. 1/2 times 4 is 2, plus 1 is 3. There we go. My two solutions are x equals 3, y equals 4. That's how you do it. Done. For this one, before we start, I don't want to deal with fractions like how they have it. So what I'm going to do is I'm going to start by multiplying the top one by the least common denominator of 4 and 5, which is 20. And for the bottom one, I'm going to multiply it by the LCM of 4 and 3, which is 12. Okay, let's write that out. So throwing this directly into a matrix, 20 times 3/4, that's 15x. 20 times 3/5 negative is negative 12, okay? And then 20 times 4 is 80. 12 times 1/4 is 3. 12 times 2/3 is 8. And 12 times 1 is 12. Oh, that's supposed to be an 80. Sorry. Okay, let's begin. First, let's flip that to a 1. So I'm going to multiply row 1 by 1 over 15. Let's write that out. 1/15 times 15 is 1. 1/15 times negative 12 is negative 12/15, which is, if you divide by 4 and 4, it's negative 4/5. And then 1/15 times 80 is 80 over 15, which can be reduced to 16/3. Next, I'd love to flip that to 0. So I'm going to multiply row 1 by negative 3, and I'm going to add it to row 2 to get our new row 2. Let's write that out. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times negative 4/5 is 12/5, plus 8, which is the same as 40/5. That's going to be 52 over 5. And then negative 3 times 16/3, that's negative 16, plus 12 is negative 4. Great. Okay, now I'd love to flip this to a 1. I'm going to do that by multiplying by the reciprocal of 52 over 5, which is 5 over 52. That times 0 is 0. This times 52 over 5 is 1. And then this times negative 4, that's going to be negative 20 over 52, which you can divide top and bottom by 2, and you get negative 10 over 26. Do it again, and you get negative 5 over 13. Last but not least, we need to flip that to a 0, so I'm going to multiply row 2 by 4/5 and add it to row 1. Let's make some room. All right, so we got 4/5 times 0 plus 1 is 1. 4/5 times 1 plus negative 4/5 is 0. And then we got 4/5 times negative 5 over 13, which the 5s would cancel out, and you get negative 4 over 13. And then we're adding that to 16 over 3. Okay, let's get some common denominators. I'm going to multiply this by 13 over 13, this one by 3 over 3. That's going to give us that nice common denominator of 39. So we got negative 12 over 39, and then plus 13 times 16, that's 160, plus 48 is 208 over 39. And then, we do 208 minus 12, which would be 196 over 39. So those are our two solutions. We've got x is 196 over 39. Y is negative 5 over 13. That's how you do it. Done. So for this one, we want to solve with Gaussian elimination. And pretty much we're almost to the answer, to be honest, because all we need to solve this successfully is to have a nice little diagonal thing of ones like so, and then zeros all around it. So we almost have that. We just got to flip that to a 0. So really we only need one step. That's going to be multiplying row 3 by a negative, adding it to row 2, and giving me my new row 2. So let's write that out. So negative times 0 is 0, plus 0 is 0. Negative times 0 is 0, plus 1 is 1. Negative 1 plus 1 is 0. And negative 87 plus 45 is negative 42. So those are the three solutions. X is 31. Y is negative 42. Z is 87. That's how you do it. Done. So for this one, for Gaussian elimination, we got to get that nice diagonal of 1s. Everything else has to flip to 0. So this column is pretty much good to go. The thing I want to work next on is flipping that to a 1. So I'm going to multiply row 2 by 1/5. Let's write that out. 1/5 times 0 is 0. 1/5 times 5 is 1. 1/5 times 6 is 6/5. And then 1/5 times 7 is 7/5. Great. Okay, now we can zero this one out. This 0 is already good to go. So I'm going to multiply row 2 by -2, and then I'm going to add it to row 1 to get a new row 1. Let's write that out. So we got -2 times 0 plus 1 is 1. -2 times 1 plus 2 is 0. -2 times 6/5, that's -12/5. And then plus 3, which could be written as 15/5, right? So we add those together and we get 3/5. And then -2 times 7/5 is -14/5 plus 4, which is the same as 20/5, right? And then so that would be +6/5. Okay, next what I'd love to do is I'd love to flip this one to a 1. So I'm going to multiply row 3 by 1/8. Let's write that out. So we got 0 and 0. Both times 1/8 is 0. Times 8 is 1. And times 9 is 9/8. All right, now what we got to do is flip this and this to 0. So let's go one at a time. First, I'm going to multiply row 3 by -6/5. And then I'm going to add that to row 2 to get a new row 2. Let's write it out. So that times 0 is 0 plus 0 is 0. Times 0 is 0 plus 1 is 1. And then times 1 is -6/5 plus 6/5 is 0. And then we got -6/5 times 9/8. That is going to be -27 over 20. So -27 over 20 plus 7/5, which could also be 28 over 20, right? We add those, we multiply by 4 over 4. Add those together and I get 1 over 20. Last but not least, we need to get this to 0. So I'm going to multiply row 3 by the -3/5, opposite of 3/5, right? And I'm going to add that to row 1 to get a new row 1. Let's make some room and write it out. -3/5 times 0 is 0 plus 1 is 1 times 0 is 0 plus 0 is 0. And then times 1 is -3/5 plus 3/5 is 0. Okay, -3/5 times 9/8. That is -27 over 40. And then we're adding that to 6/5, which if I multiply by 8 over 8 is 48 over 40. Okay, and that's going to simplify to evaluate to 21 over 40. So those are my three answers for X, Y, and Z. We got 21 over 40 for X, 1 over 20 for Y, and 9 over 8 for Z. That's how you do it. Boom, done. All right, so for this question, the way we're going to start is first putting it into matrix format, but I'm also going to simultaneously simplify this third row by dividing it by 2. So let's do that now. So 4 divided by 2 is 2. That's going to be -4. That's going to be 1, right? 2 divided by 2 is 1, and -6 divided by 2 is -3. Next, I can zero this out really easily by adding the first row to the third row, and making that the new third row. Let's write that out. So we got -2 plus 2 is 0. 3 plus -4 is -1. -2 plus 1 is -1, and 3 plus -3 is 0. Great. Next, we're going to multiply the first equation by 2 and add it here to zero that out. So let's do that now. So 2 times row 1 plus row 2 to give a new row 2. So we got 2 times -2 plus 4 is 0. 2 times 3 is 6 plus 2 is 8. 2 times -2 plus -1 is -5, and 2 times 3 is 6 plus 9 is 15. Next, let's flip this guy to a 1. I can do that by multiplying row 2 by 1/8. Let's write that out. So we got times 0 is 0, times 8 is 1, times -5 is -5/8, and then times 15 is 15 over 8. Next, I can zero out this value very easily by just simply adding the second row to the third row. So let's do that now. So this will equal the new third row. Here we go. So we get 0 plus 0, 0, 1 plus -1, 0, -5/8 plus -1. That's going to be -13/8. And then we got 15/8 plus 0 is 15/8. Now I'd love to flip this into a 1 so I can simply multiply the third row by the reciprocal, which is -8 over 13. Let's check that out. So we got 0, 0, and then this times its reciprocal is 1, and then -8 over 13 times 15 over 8. Look what happens, right? 8's cancel out and you're left with negative 15 over 13. Great. So next I'd love to eliminate this to a 0, the negative 5/8. So I'm going to multiply row 3 by 5/8 and add it to row 2. Let's do that now. So we got 5/8 times row 3 plus row 2 to get a new row 2. Let's write it out. So we got 0 plus 0 is 0. 0 plus 1 is 1. And then 5/8 times 1 is 5/8 plus negative 5/8 is 0. And then 5/8 times negative 15. Here, let's write that out. 5/8 times negative 15 over 13. That's negative 75 over 104 plus 15 over 8, which is, if I multiply by 13 over 13, I get 104, and then that would be 195, I believe. And 195 minus 75 is 120, right? 120 over 104. And we can reduce that by dividing top and bottom by 8 to get 15/13 positive. All right, now we need to fix that first row, and I'd love to zero these two out and then flip that to a 1. All right, so first I'm going to multiply the top row by negative 1/2. Okay, so let's do that now. So we got negative 1/2 times negative 2 is 1, times 3 is negative 3/2, times negative 2 is 1, and then times 3 is negative 3/2. Great. Now I got to zero this out and that out. So first let's zero this out because I can do that by multiplying row 3 by negative 1 and adding it to row 1 to get a new row 1. So we got 0 plus 1 is 1. 0 plus negative 3/2 is negative 3/2. And then negative 1 plus 1 is 0. And then negative 15/13 is positive 15/13 plus negative 3/2. So let's get common denominators. And we could get 26, right? So 13 and 13, and then 2 and 2. So that'd be 30 minus 39 over 26, which is negative 9 over 26. So that goes up here. Okay, last but not least, we have to flip that to 0. So I'm going to multiply row 2 by positive 3/2 because that's negative 3/2. I know it looks a little funky, but then we're going to add them together. So let's do that now. So this is going to give me a new row 1. This will be the final step here. So let's check this out. So we got times 0 is 0 plus 1 is 1 times 1 is 3/2 plus negative 3/2 is 0 times 0 is 0 plus 0 is 0. And then we have 3/2 times 15 over 13. That's going to be 45. Hold on, let me write it out here. 45 over 26 plus negative 9 over 26. Okay, so that's nice. They already have a common denominator. 45 minus 29 is 36 over 26, which you can divide top and bottom by 2, and you get 18 over 13. So then my final answer is 18 over 13 for x, 15 over 13 for y, and negative 15 over 13 for z. That's how you do it. Done. So for this one, let's start by putting it into our nice matrix format. Now you notice that for these two equations, they can be divided by numbers, right? Common factors. So this one can be divided by 2. This one can all be divided by 5. So let's do that now. I'm just going to make that into one step. So we're going to say 1/2 times row 2 and 1/5 times row 3. And we're going to write that out up here. So half of this is negative 2, negative 3, negative 2, negative 1. And this one would be 1/5 of that is 2, 3, and then 1/5 of that is 2, 1/5 of that is 1. Okay. Now this is very interesting. If you look at these two equations, they look identical because I can just multiply this one by negative 1 and go, watch, boom, 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 boom. And that's the same as the top. So what does that tell you? That means that all three of these equations are exactly the same. So in this case, there are, of course, infinite solutions. And the way that we can represent this is, because it's basically the same equation 3 times, we can go back to the simplest version of that equation, which is 2x plus 3y plus 2z is equal to 1. And we can find corresponding values of z depending on what we choose for x and y. And the way we're going to do that is we're going to isolate z. So for example, I'm going to say 2z is equal to 1 minus 2x minus 3y, right? Isolating. And then we're going to divide both sides by 2. So there's my representation of z in terms of x and y. So now if I give the values, right, the solution, we got x, whatever we plug in there, and y, whatever we plug in there. And then based on that, our z is going to be equal to 1 minus 2x minus 3y divided by 2, like so. And that is your final answer. Done. So for this one, let's go ahead and put this into matrix format. The one thing that I'm noticing right off the bat is that this whole equation can be divided by 3. So I'm going to do that simultaneously as we put in the values. So divided by 3, that's going to be 1, that's going to be 2, that's going to be -1, and that divided by 3 is 1. Great. The first thing I want to do is I'm actually going to add row 2 to row 3 because that's going to nicely, just as is, zero out both of these, which we do want eventually. So I'm going to say row 2 plus row 3 is going to give us a new row 3. Let's write it out. -1 plus 1 is 0. -2 plus 2 is 0. 2 plus -1 is 1. -2 plus 1 is -1. Great. And look at that. We even got a 1 there, which is what we want eventually. And that does already tell us our value of z. But let's keep going. Next, I'd love to flip this to a 0. And I can do that easily by just saying row 1 plus row 2. So let's write that out. So this is going to give us our new row 2. Here we go. So 1 plus -1 is 0. 2 plus -2 is 0. -1 plus 2 is 1. And then 1 plus -2 is -1. Cool. So it's very interesting. We kind of get a repeat in here and here, right? Now, if we look back, you will notice this was actually equivalent to this. So we really got just 2 equations, right? This one and this one are the same, and then you got this one. So we've already now concluded double, right? 2 times, that z is equal to -1. Now we have to get the relationship between x and y as well. The way we can do that is one more step. We can add row 2 to row 1 to get a new row 1. Check this out. So we got 0 plus 1 is 1, 0 plus 2 is 2, 1 plus -1 is 0, and -1 plus 1 is 0. Okay, so now I'm going to make a little bit more room, and we've got what we need here to get our last component, right? We've got, and I'm going to turn it back into the equation format. 1x plus 2y is equal to 0. So now if I subtract 2y from both sides, I see that x is equal to -2y. Further isolating, y is equal to -x over 2, right? So now I have a representation for y in terms of x, and I already know that z has to be -1, so I can place my final answer as x is x, y is -x over 2, and then z, as we already know, is -1. So that is how you do it. Done. For this one, let's start by putting it into matrix format. So we got 1, 1, 1, 100, then we got 1, y is 0, z is 2, and then 125, and then the coefficients here, x is 0, y is -1, z is 2, and 25. There we go. We've already got some nice things here with the 1 starting off and some zeros, but right off the bat, what I can see is I can flip that to a 0 pretty easily, and I can do that by doing negative row 1 plus row 2. But the good thing about this, to get a new row 2, is that I don't want that to be a 0, but this is going to take care of that. It's going to change it to a -1. So let's check it out. So -1 plus 1 is 0. -1 plus 0 is -1. -1 plus 2 is 1. -100 plus 125 is 25. Great. Next, I'd love to flip this to a positive 1. So I'm going to multiply row 2 by -1. Let's check it out. So we got 0 stays 0, -1 flips to 1, 1 flips to -1, and that flips to -25. All right, now we can zero out this one pretty quickly, and I'm going to do that by just saying row 2 plus row 3 gives us a new row 3. Let's write it out. So we got 0 plus 0 is 0, 1 plus -1 is 0, -1 plus 2 is 1, -25 plus 25 is 0. Great, we already got our z value is 0. All right, let's keep it going. Next, I'm going to flip that to a 0. So we're going to again multiply row 2 by -1, but add it to row 1 to get a new row 1. Let's check it out. So we got 0 plus 1 is 1, -1 plus 1 is 0, positive 1 plus 1 is 2, and then we got positive 25 plus 100 is 125. All right, it's looking pretty good. We only got 2 things to flip to a 0, which is this guy and this guy. Let's start with row 2, and I'm just going to straight up add row 3 as is to row 2 to get a new row 2. Let's write it out. So we got 0 plus 0 is 0, 0 plus 1 is 1, 1 plus -1 is 0, and 0 plus negative 25 is negative 25. There we go. We got our y value. Last but not least, we got to flip this. So I'm going to multiply row 3 by negative 2, add it to row 1 to get a new row 1. Let's check it out. So we got negative 2 times 0 plus 1 is 1. Negative 2 times 0 is 0 plus 0 is 0. Negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 0 is 0 plus 125 is 125. And there we have it. Those are our three answers. So x is 125, y is negative 25, and z is 0. That's how you do it. Done. So for this one, I got some crazy fractions. This is going to look terrible if we don't convert them. So what I want to do is I want to get rid of the fractions, and I can do that by multiplying by the least common denominator in each of these equations. So for this one, 2, 7, and 14, that would be 14, and I'm going to, let's make it negative 14, just so we flip that first one to a positive. This one, I'm going to multiply by, let's see, 2, 2, and 4, so I'll multiply by 4. And this one, I'm going to multiply by 15, 3, 5, 4. Let's see, that would be 60. Okay, so let's write it out. So distribute the negative 14, we get 7, negative 7, negative 2, and then that one would be positive 53. Over here, we'd have 2, negative 2, 1, and 12. And then down here, 1/4 of 60 is 15, 1/5 is 12, 1/3 is 20, and then we multiply here. 15 and the 60 cancel out to a 4. 4 times 23 is 92. So to start this one, I'm going to first divide row 2 by 2, or basically multiply it by 1/2. And actually, we're going to flip that to a negative so that this becomes a positive 1, because we want that 1 to be a 1. So we got negative 1, positive 1, negative 1/2 over here, and then negative 6 here. Next, I'm going to flip this one to a 1, and I'm going to do that by multiplying the top row by 1/7. So I know we're going to go back to getting some fractions here, but I think this is the best play. So then we got 1, negative 1, and then we got negative 2/7 and positive 53 over 7. Next, I'm going to add row 1 as is to row 2 and set that equal to a new row 2. Let's write that out. 1 plus negative 1 is 0. Negative 1 plus 1 is 0. Negative 2/7 plus negative 1/2, that's going to be negative 4/14 minus 7/14, which is negative 11/14. And then 53 over 7 plus, okay, so let's write that out. 53 over 7 plus negative 6 would be negative 42 over 7. 53 minus 42, what is that? 11. So it's positive 11 over 7. Now, when you look at this second row, usually you want this to be a 1, but it's gone. It's gone to 0. So what I'm going to do is I'm going to actually swap these two rows. We're allowed to do that. So that would be a perfect row 3. So let's switch it down. So then we got 15, 12, 20, and 92 up here. And then we got 0, 0, and then we got negative 11/14, and then 11/7. Okay, why don't we flip this one to a 1? That's going to be pretty easy. I just multiply by that reciprocal against row 3. So I multiply by negative 14 over 11. Let's write that out. So we got 0, 0. That times its own reciprocal is 1, and then negative 14 over 11 times 11 over 7. These cancel out. Negative 14 over 7 is negative 2. All right, now let's work on some of these other numbers. So maybe now let's go ahead and zero this guy out, and I'm going to do that by, let's make some more room. I'm going to multiply row 3 by 20, and I'm going to add it to row 2 to get a new row 2. So we got 0 plus 15 is 15, 0 plus 12 is 12, and then negative 20 plus 20 is 0, and then we'd have positive 40 plus 92 is 132. Next, I'd love to flip this to a 0. We can do that with row 3 pretty easily. So I'm going to say 2/7 times row 3 plus row 1 is going to give us a new row 1. Let's write it out. So we got 2/7 times 0 is 0 plus 1 is 1 times 0 is 0 plus negative 1 is negative 1 times 1 is 2/7 plus negative 2/7 is 0. And then times negative 2 is negative 4/7 plus 53/7 on the top. So negative 4 plus that is going to be 49 over 7. Divide 49 over 7 reduces to 7. That's a nice whole number. Excellent. Next, we can flip this to a 0 by multiplying row 1 by negative 15 and adding it to row 2. So let's do that now. Negative 15 plus 15 is 0. Positive 15 plus 12 is 27. 0 plus 0 is 0. And then negative 15 times 7, that's negative 70, 30, negative 105 plus 132 is 27. All right, now look how great this is. I can literally multiply row 2 now by 1/27th, right? That's going to immediately give me the 1 in the middle. So let's do that now. So that times 0 is 0. That times that is 1. That times 0 is 0. And then that times that is again 1. Look at that. So we got a nice whole number for y. It's also 1. Last but not least, we got to flip this. To do that, I'm going to just simply add row 2 to row 1. That's the last move. So we got 0 plus 1 is 1. 1 plus negative 1 is 0. 0 plus 0 is 0. 1 plus 7 is 8. So there it is. We're done. Our final answer is 8 for x, 1 for y, negative 2 for z. That's how you do it. Done. All right, so for this one, before we start, I want to clear out the fractions here and here for those first two equations. So let's go ahead and do that now, and then after that, we'll put it in the nice matrix format. But by the way, that second equation we're not going to change, so that's still going to be 1, 1, 1, and 6. So that's perfect. This top one, I'm going to need to multiply by the least common multiple of 7, 8, and 4, which is 56. And this one, least common multiple of 3 and 3, which is just 3. All right, let's do the first top one first. So 56 times this, you divide by 7 and you'd get 8. So 8 times x minus 1 plus 56 times this, you divide by 8, that's 7. So we get 7 times y minus 2. And then 56 divided by 4 is 14 times z minus 3. And that's all going to equal 0. Now let's simplify, distribute, like for all of these. And then we get 8x minus 8 plus 7y minus 14 plus 14z minus 42 is equal to 0. Now as we combine negative 8, negative 14, and negative 42, that's negative 22 plus negative 42 is negative 64. So we got 8x plus 7y plus 14z is equal to 64 because we're going to add it to both sides. So that's going to be the new first equation. So we enter in 8, 7, 14, and 64. All right. Now for this one, it's going to be a little easier, a little bit of less work. Multiply everything by 3. The first one becomes x plus 2. That times 2y is 6y. That times that just cancels out the denominator, so we get plus z minus 3, and that's equal to 15. All right, combine these together. 2 and negative 3, that's negative 1. So I add 1 to that side, and I get 16 is equal to x plus 6y plus z. So the bottom one is going to be 1, 6, 1, and then 16. Great. All right, now let's clear all this work. So what I see right off the bat is a really nice opportunity to zero out these two. Right? I can just multiply row 3 by negative, add it to row 2 to get a new row 2. So let's do that now. So we get negative 1 plus 1 is 0. Negative 6 plus 1 is negative 5. Negative 1 plus 1 is 0. And then negative 16 plus 6 is negative 10. All right, next we can easily flip that to a 1 by multiplying negative 1/5 times row 2. And let's do that now. So we got that times 0 is 0. That times negative 5 is 1. Times 0 is 0. And times negative 10, that's a nice 2, nice whole number. So now we know that y is equal to 2. All right, let's keep going. So, and by the way, you know, we got a 1 here and a 1 here. This is great because we actually want to keep this 1. This one we need to flip to 0. But let's first go to the second row and let's multiply it by negative 6, okay? And then we're going to add it to row 3 to get a new row 3. That's going to flip this one to 0 pretty nicely. So let's do that now. So then we got 0 plus 1 is 1. Negative 6 plus 6 is 0. 0 plus 1 is 1. And then negative 6 times 2 is negative 12 plus 16 is 4. Great. Now I'd love to flip this to a 1. So to do that, I'm going to multiply row 1 by 1/8. Okay, we're going to get some fractions, but it's all good. So we got 1/8 of 8 is 1. 1/8 of 7 is 7/8. 1/8 of 14 is 14/8, which is 7/4. And then we got 1/8 of 64, which is just 8. Next, I'm going to zero this one out pretty easily by multiplying row 2 by negative 7/8, adding it to row 1 to get a new row 1. Let's check it out. So we got that times 0 is 0 plus 1 is 1. That times 1 is negative 7/8 plus 7/8 is 0. Times 0 is 0 plus 7/4 is 7/4. And then negative 7/8 times 2 is negative 7/4 plus 8, which is the same as 32 over 4. So negative 7 plus 32 is 25 over 4. All right, next we can zero out this guy by multiplying row 1 by negative 1 and adding it there. So let's make a little room here. So we got negative 1 plus 1 is 0. 0 plus 0 is 0. Negative 7 fourths plus 1 is negative 3 fourths. And then negative 20, it would be negative 25 fourths plus 4, which is 16 fourths. And you add those together and it's negative 9 over 4. Okay, great. Now I want to flip this guy to a 1 and I'm going to multiply it by its reciprocal, negative 4/3 times row 3. Let's write it out. So times 0 is 0, times 0 is 0, times its reciprocal is 1, and then times negative 9 fourths. These are going to cancel. Negatives are going to cancel. 9 over 3, which reduces to 3. All right, last but not least, we're going to zero out this guy. I'm going to do that by multiplying row 3 by negative 7 fourths, adding it to row 1 to get a new row 1. Let's write it out. So we got negative 7 fourths times 0 plus 1 is 1, times 0 is 0, plus 0 is 0, times 1 is negative 7 fourths, plus 7 fourths is 0, just like we wanted. And then times 3 is negative 21 fourths, plus 25 fourths. That's going to give us 4 fourths, which is 1. So there's your final answer. X is 1, Y is 2, Z is 3. That's how you do it. Done. So for this one, we're going to start by clearing these fractions out by multiplying by the LCM of 4 and 3, which is 12. And for this one, just by 2. Okay, and then we're going to put that into that nice matrix form. By the way, the one on the bottom, we're not changing, so that's 1, 1, 1, and 1. Okay, so let's do this out here. So 12 distributing that. We say 12 divided by 4 is 3. So we got 3 times x minus 3. 12 divided by 3 is 4. So we got minus 4 times y minus 1. 12 times 2 is 24z is equal to negative 12. Let's simplify. Distribute, 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 distribute. 3x minus 9 minus 4y plus 4. Don't forget the negatives. Distribute and cancel out. Plus 24z is equal to negative 12. Let's combine like terms. Negative 9 and 4 make negative 5. And then we add it to the other side, and we got 3x minus 4y plus 24z is equal to negative 7. So in the matrix, we got 3, negative 4, 24, and negative 7. And then when we multiply by 2, it just clears out everything in that second equation. X plus 5, y plus 5, z plus 5 is equal to 16. 5, 5, and 5 make 15, right? And then I subtract 15 from both sides and I get 1 equals x plus y plus z. So that's the exact same as the third equation, 1, 1, 1, 1. Now, when we have a situation like this, because these are identical equations, we can pretty much zero this out. And the row operation to do that, by the way, would be to multiply row 2 by negative 1, add it to row 3. So we can pretty much get rid of that. Now this is going to be an infinite solution situation, so we have to figure out the relationships of z and y to x to be able to express this correctly. So what I'm going to do is I'm going to take this second equation and I'm going to multiply it by 4. Okay, so I'm going to say row 2 times 4, and I'm going to add that to row 1 to get a new row 1. So you're going to see y. It's going to zero out the y value, so check it out. So we got 4 plus 3 is 7. 4 plus negative 4 is 0. 4 plus 24 is 28. And then 4 plus negative 7 is negative 3. So now let's turn this back into the variable equivalent equation, which is 7x plus 0y plus 28z is equal to negative 3. Now I want z in terms of x, so I got 28z is equal to negative 7x minus 3, divide by 28, divide by 28. And there's my expression for z. It's negative 7x minus 3 over 28. Now I'm going to do the same thing, but I'm going to take this and I'm going to zero out the z value. So I got negative 28 times row 2 plus row 1 equals row 1. Let's write it out. So I got negative 28 plus 7 is negative 21. Negative 28 plus 0 is negative 28. Negative 28 plus 28 is 0. And then negative 28 plus negative 3 is negative 31. So then I have negative 21x minus 28y is equal to negative 31. So now let's isolate y. So we're going to add 21x to both sides. So negative 28y equals 21x minus 31. Last but not least, divide by negative 28. Divide by negative 28. And there's our expression for y. It's 21x minus 31 over negative 28. So now our final solution can be x is x, y is right here positive 21x minus 31 over negative 28. And last but not least, we got that one for z, negative 7x minus 3 over 28. And that's how you do it. Done. So for this one, we're going to start by clearing out these denominators. I'm going to multiply this top one by the LCM of 3 and 4, which is 12, and this one just 2. Okay, so let's simplify that, and then we're going to also put it into our nice matrix format with the bottom one staying as is, 1, 1, 1, 1. Okay, let's go. So 12 divided by 4 is 3, so we got 3 times x minus 3. And then 12 divided by 3 is 4, so we got minus 4 times y minus 1. And then we got 12 times 2, which is 24z, is equal to 12 times negative 1 is negative 12. Distribute, 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 distribute. We got 3x minus 9 minus 4y plus 4. And then plus 24z is equal to negative 12. Combined like terms, that's going to be a negative 5. Add that to that side, and we get negative 7. Over here, we got 3x minus 4y plus 24z. So that's going to go in as 3, negative 4, 24, and negative 7. Okay, then when we distribute that 2, we got x plus 5 plus y plus 5 plus z plus 5 is equal to 7. Add 5, 5, and 5, and we get 15, right? Minus 15 from both sides, and we get negative 8. So we get x plus y plus z equals negative 8. So that will go in as 1, 1, 1, negative 8. All right, let's clear this out. Now, when we look back at this, what do we have? I have 1x plus 1y plus 1z equals negative 8. But then I have 1x plus 1y plus 1z, the exact same arrangement, equaling 1. That's not possible. I can't have this and this equaling, which are the exact same, equaling two different numbers, which means that this must be a no solutions situation. So that's how you do it. Done. Ebagari's competing cupcake store, 4,520 cupcakes worth of cupcakes are sold daily. The chocolate cupcakes cost $2.25, red velvet costs $1.75. If the total number of cupcakes sold per day is 2,200, how many of each flavor are sold each day? All right, so first, let's set this up into a nice equation. So we'll say chocolate is X, red velvet is Y. So we say X plus Y, these are the numbers of each, is equal to that total of 2,200. And then for the other ones, I can use the price, right? Chocolate, which is $2.25 per one sold. That one is $1.75 per the red velvet sold, is equal to a total amount of 4,520. Okay, now we can make our augmented matrix. So let's check it out. And it's going to be a 2 by 2 with the constants over here. So we got 2,200 for the top one, 4,520 over here. And then the coefficients there are 1 and 1 here. It's 2.25 and 1.75. Great. So first, let's flip this to a 1. And the really easy way to do that is I can divide the bottom row by 1.175, aka multiply it by 1 over 1.75. So that's on row 2. Let's rewrite it. So when I multiply this guy, it becomes a pretty crazy decimal, or I can write it as 9 over 7 times this is just 1. And when we multiply it against this, it turns into a fraction. Again, a pretty crazy one, but we'll say it's simplified as 18,080 over 7. So now we can start to flip this to a 0 and this to a 0. First, let's flip the 9/7. So I'm going to say negative 9/7 times row 1 plus row 2 is going to give me a new row 2. So negative 9/7 plus 9/7 is 0. Negative 9/7 plus 1 is negative 2/7. And then negative 9/7 times 2,200 plus this is negative 19,800 over 7 plus 18,080 over 7. And that's going to be negative 1,720 over 7. So let's put that in here. Okay, so next step, I'd love to convert that to a 1. So I'm going to multiply the row 2 by the reciprocal of negative 2/7, which is negative 7 over 2. Let's write that out. So we got times 0 is 0, times that is 1, and then times this, times negative 1720 over 7. The negatives are going to cancel out, so are the 7s. And then it's 1720 divided by 2, which is 860. Last but not least, we got to flip that to a 0. So all I'm going to do is multiply row 2 by a negative and add it to row 1 to get a new row 1. So we got 0 plus 1 is 1. We got negative 1 plus 1 is 0. And then negative 860 plus 2200, that is 1340. All right, so that means we have 1340 chocolate and we have 860 red velvet. That's how you do it. Done. You invested $2,300 in one, $2,700 in two. If the total amount of interest after 1 year is $254 and account 2 has 1.5 times the interest rate of account 1, what are the interest rates? Okay, so if we say account 1 and account 2, what we're trying to do is we're trying to figure out the interest rates, right? So we can say the interest rate for 1 is X, the interest rate for 2 is Y. And we got a couple of relationships. So first of all, we have 2,300 times whatever that interest rate is, which is X, plus 2,700 times whatever that interest rate is, which is Y, is going to equal the total interest, which is 254. That's for 1 year, right? That's just using our simple interest formula. And then it says, we have another relationship. It says that the account 2 interest rate is 1.5 times account 1, okay? So I'd love to get this in a similar format. So all I'm going to do is I'm going to subtract 1.5x from both sides. So I get negative 1.5x plus 1y, and that's now equal to 0. Okay, now I can make my augmented matrix, right? So we have 2,300 for the coefficient of x, 2,700 for the coefficient of y, and then 254 for the constant. Here we have negative 1.5. Here we have 1, and then we have 0. First things first, let's zero this guy out. That's going to be pretty easy. We're going to multiply 2,700 times row 2 and add it to row 1. Let's do that now. So negative 2,700 times negative 1.5 is 4,050. 4,050 plus 2,300 is 6,350. I know it's a big number, but we're going to get rid of it eventually. Then I got this times 1 is negative 2,700 plus positive 2,700 is 0. And then this times 0 is 0 plus 254 is 254. Okay, now we can easily flip that to 1 by multiplying by its reciprocal. So let's do that now. So this times that is 1, this times 0 is 0, and then this times 254 is 0.04. Okay, and that's my x value. And now we got to get this one, all right? All I got to do is zero this out. So I'm going to multiply row 1 by 1.5 and add it to row 2 to get a new row 2. Let's write it out. So we got 1.5 plus negative 1.5 is 0. 0 plus 1 is 1. And then 1.5 times 0.04, that's 0.06 plus 0 is 0.06. So this being in decimal format means for account 1, the interest rate was 4%. For account 2, it's 0.06 or 6%. So that's how you do it. Done. Major appliance stores agreed to order vacuums from a startup founded by college engineering students. The store would be able to purchase vacuums for $86 each with delivery of $9,200 regardless of how many vacuums are sold. If the store needs to start seeing a profit after 230 units are sold, how much should they charge for the vacuums? Okay, so the price of the vacuums is X. So essentially the break-even point is 230 units. So what we can say is 230 units times some selling price X. And then we'd say minus 86 times the same 230, right? Because that's how much you're buying all those 234 at $86. Minusing again that 9,200 delivery fee, and this is supposed to equal 0. So this is kind of interesting because this doesn't even seem like we need a matrix. This is a singular equation. Let's solve and see what we get. So 86 times 230 is 19,780, and then minus 9,200 equals 0. Now we can add these two together. 230x minus, that'd be 28,980 is equal to 0. Then I'm going to add that to the other side, right? So it's equal to positive 28980. And then we divide by 230. Divide by 230. And we get x is equal to 126. So the price that they should charge is $126. So I don't know why we would even need a matrix for this, but that's the answer. That's what matches in the back of the book. That's how you do it. Done. At an ice cream shop, 3 flavors are increasing in demand. Last year, banana, pumpkin, and Rocky Road, I'm going to call that X, Y, and Z. I'm sure it's a triple system, made up 12% of the total ice cream sales. This year, the same 3 ice creams made up 16.9% of the ice cream sales. The Rocky Road sales doubled, the banana sales increased by 50%, and the pumpkin sales increased by 20%. Okay, if the Rocky Road ice cream had 1 less percent of sales than banana, find out the percentage. Okay, we got a lot of information here, so let's kind of put this out there. So first of all, X, Y, and Z are going to represent percentages. And in particular, this will represent last year's percentages. So X, Y, and Z are last year's percentages, and all three added up, it says it equals 12%. Okay, great. Now it says this year they made up 16.9%, but we want to still have the same three variables. And what it says is Rocky Road doubled. So Rocky Road is now 2Z. The banana sales increased by 50%. Banana is X. So by increasing by 50%, it's like multiplying by 1.5. And then the pumpkin sales increased by 20%, which is like multiplying by 1.2. So there we have a second equation. And then now we need a third equation, right? Three variables, we need three equations if we're going to solve. Then it said the Rocky Road had 1 less percent of sales than the banana. So Rocky Road, which we said is Z, but I'm assuming they mean this year. So they're saying this year 2Z is 1% less than banana. And I again assume they mean currently, which is 1.5x, right? That's our third equation. So now we have three equations. Let's see if we can solve. Now in this last sentence, it says if Rocky Road, and I'm assuming it's the previous, right? So it's our original variable. If Rocky Road had 1% less than banana, which we said was X. And now we got a triple system. Now let's solve. So the first thing I'm going to do with this one is I'm going to rearrange it by bringing the variable over here. So it's going to be negative X plus Z is equal to negative 1. And now we're going to rewrite it to line it up here. So we got negative X Z plus Z, right? We have no Y. We can even say 0Y just to have something, is equal to negative 1. Okay, now we got enough information to put it into a matrix. Let's do that down here. So we got 1, 1, 1, 12. We got 1.5, 1.2, 2, and 16.9. And last one down here, we got negative 1, 0, 1, and negative 1. So this is looking great right off the bat. Some nice, easier numbers. So I can zero out this guy and this guy first. I'd love to zero out this one first because that's pretty easy. All I do is row 1 plus row 3 is going to give me a new row 3. Let's write that out. So I got 1 plus negative 1 is 0. 1 plus 0 is 1. And 1 plus 1 is 2, and then 12 plus negative 1 is 11. Great. Now let's zero out this guy. I'm going to multiply the top row by negative 1.5 and add it to row 2. Let's write that out to get a new row 2, right? So we got negative 1.5 plus 1.5 is 0. Negative 1.5 plus 1.2 is negative 0.3. And negative 1.5 plus 2 is positive 0.5. And then negative 1.5 times 12 is negative 18. Plus 16.9 is negative 1.1. Next, I'd love to just get this decimal gone. So multiply entire row 2 by 10, and we get 0, negative 3, 5, negative 11, and then the top stays the same. Then I'll divide the entire row 2 by negative 3, or multiply it by negative 1/3. So we get 0, negative 1/3 times negative 3 is 1, negative 1/3 times 5 is negative 5/3. And then negative 1/3 times negative 11 is 11/3 positive. Next, we can zero out this guy and this guy by just multiplying row 2 by a negative and adding to row 1 to get a new row 1, and doing the same thing to row 3 to get a new row 3. We can do that in one step. Let's write that out. So we got 0 plus 1 is 1, negative 1 plus 1 is 0, positive 5/3 plus 1, which is 3/3, is going to be 8/3. And then negative 11/3 plus 12, which is 36/3. Negative 11/3 plus that is 25/3. Okay, now the row 3, excuse me. So then we got 0 plus 0 is 0. Negative 1 plus 1 is 0. Positive 5/3 plus 2, which is 6/3. That gives us positive 11/3. And then what do we have here? Negative 11/3 plus 11, which would be negative 11/3 plus 33 over 3, which is 22 over 3. Great. Next, I'm going to flip that to a 1 by multiplying row 3 by the reciprocal of that, which is 3/11. Let's write that out. So we have 0, 0, 3/11 times 11/3 is 1. 3/11 times 22 over 3 Cancel, cancel. 22 divided by 11 is 2. So there's our first answer. Z is equal to 2. Okay. Now we got to flip both of these to 0. First, I'm going to multiply row 3 by 5/3 positive, add it to row 2 to get a new row 2. Let's write that out. So we got 0 plus 0 is 0. 0 plus 1 is 1. 5/3 times 1 plus negative 5/3 is 0. And then 5/3 times 2 is 10/3 plus 11/3 is 21/3, which simplifies to 7. Last but not least, we're going to multiply row 3 by negative 8/3 to flip that to a 0. So we're going to add it to row 1 to get a new row 1. Let's write it out. So we got 0 plus 1 is 1. 0 plus 0 is 0. Negative 8/3 plus 8/3 is 0. And then we got negative 16/3 plus 25/3, which is 9/3, and that reduces to 3. So our answer is 3, 7, 2. But if we link it back to the original preface, we have percentages for banana, pumpkin, and rocky road. So banana was 3%, pumpkin was 7%, and rocky road was 2%. And that's how you do it. Done. A bag of mixed nuts contains cashews, pistachios, and almonds. So I'll call that X, Y, and Z. Originally, there are 900 nuts in the bag. 30% of the almonds, 20% of the cashews, and 10% of the pistachios were eaten. And let's underline those numbers. And then it says, and then there are 770 left in the bag. Originally, there were 100 more cashews than almonds. Okay. That's 3 relationships. Now we can write this out. And again, this is going to be the amount of almonds or nuts or whatever, almonds, pistachios, and cashews. So the first equation is just the amount of each. X plus Y plus Z is equal to 900. So these are the original amounts. Then when these percentages were eaten, okay, this is how much was left in the bag. So if 30% was eaten, how much is left, right? That's 70%. And that's for the almonds. So we'd have 0.7 Z, then 20% of the cashews, which is X, that would be 0.8 X, or 80% of X was left. And then 10% of the pistachios, that's Y, so then that's 0.9 Y. And all of these added up would be 770. Last but not least, it says there were 100 more cashews. So the amount of cashews was 100 more than the amount of almonds. So to get this into that nice format like we have over here, I'm going to subtract Z from both sides, right? Keep the 100 over there. X is chilling here, and we don't have a Y, so I'll just say 0Y. Now we can put this into an augmented matrix. Let's do that now. So here we have 1, 1, 1. Here we have 0.8, 0.9, and 0.7. Here we have 1, 0, and negative 1. First thing, I'd love to flip that and that to a 0. So first I'm going to multiply the top row by negative 0.8 and add it to row 2 to get a new row 2. Let's write that out. So negative 0.8 plus 0.8 is 0. Negative 0.8 plus 0.9 is 0.1. Negative 0.8 plus 0.7 is negative 0.1. And then negative 0.8 times 900 is negative 720. That plus 770 is 50. Next, let's get rid of that one. So we're going to multiply row 1 just by a simple negative, and we're going to add it to row 3 to get a new row 3. So let's write that out now. Here we go. So we got negative 1 plus 1 is 0. Negative 1 plus 0 is negative 1. Negative 1 plus negative 1 is negative 2. And then negative 900 plus 100 is negative 800. Great. Now I'm just going to multiply the second row by 10, and that's going to flip that to a 1, and it's going to get rid of those decimals, so that'll be good. So we got 0, positive 1, negative 1, and 500. Next, I'm going to add row 2 to row 3 to zero this out. So we got 0 plus 0 is 0, 1 plus negative 1 is 0, negative 1 plus negative 2 is negative 3, and 500 plus negative 800 is negative 300. Okay, great. Now we can easily flip that to a 1 by multiplying the bottom row by negative 1/3. Let's write that out. So we got that times 0 is 0, that times 0 is 0, that times negative 3 is 1, that times negative 300 is positive 100. So we know the value of Z is now 100. Okay, next I'm going to add row 3 to row 2. So we got 0 plus 0 is 0, 0 plus 1 is 1, and then 1 plus negative 1 is 0, 100 plus 500 is 600. Great. Now we got our Y value. Okay, we just got to flip these two to 0. First, I'm going to multiply row 2 by negative and add it to row 1 to get a new row 1. So we got 0 plus 1 is 1, negative 1 plus 1 is 0, 0 plus 1 is 1, and then negative 600 plus 900 is 300. And last but not least, we multiply row 3 by negative, add it to row 1 to get a new row 1. Let's write it out. Here we go. We've got 0 plus 1 is 1, 0 plus 0 is 0, negative 1 plus 1 is 0, and then negative 100 plus 300 is 200. So our final answer is 200, 600, and 100. So that is 200 cashews, 600 pistachios, and 100 almonds. And that is how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.